Hey, welcome. Today we're going to dive into two of the most powerful and, let's be real, sometimes kinda scary concepts in C programming: pointers and structures. Seriously, these are the secret sauce behind everything from operating systems to super fast game engines. So stick with me, because by the end of this, you'll see them as your new best friends.
So what makes C so special anyway? Well, it's this. Unlike a lot of other languages that hold your hand, C basically gives you the keys to the entire car. You get to directly access and manage the computer's memory. And yeah, that means you can write code that is incredibly fast and efficient. This is where the real power is.
And to handle that kind of power, you need the right tools. So today we're going to talk about the two master keys that unlock all that memory management goodness, giving you a level of control that you just can't find anywhere else.
And here they are, pointers and structures. Just think of it like this. A pointer is your map. It's the tool for finding where your data is hiding in memory. And a structure, that's your blueprint. It's the tool for building brand new, complex kinds of data. So one finds and the other builds. Let's break them down.
All right, let's get into our first power-up: pointers. The whole point of a pointer is to answer a really simple question. Not just what is the data, but where in the world does it actually live? To get pointers, you got to start with variables. So think of a variable like a house. It's just a named spot in memory that holds a value. In this example, we've got a house named X, and inside that house lives the number 10. Simple enough, right?
Okay, so every house has a unique street address so the mail carrier can find it. It's the exact same idea in C. Every single variable has a unique memory address. So when you see that little ampersand symbol and X, it's not going to give you the number 10. Nope. It's going to give you the specific street address where that 10 is stored.
And that brings us to the pointer itself. So a pointer isn't the house, and it's not the address sign on the front lawn. A pointer is like a little sticky note where you've written down the house's address. It's just another variable, but its only job is to hold the location of another variable.
So how do we actually use this stuff? Well, there are two key symbols you gotta know. The ampersand, or the address of operator, is how you ask, hey, what's the address of this variable? And the asterisk, or the dereference operator, is how you say, okay, go to the address on this sticky note and tell me what's inside the house.
Okay, I get it. That's the what, but it all feels a little abstract. So why would we go through all this trouble? Why is knowing the address of something so ridiculously useful? Well, here's a classic problem in C. When you pass a variable to a function, that function just gets a copy of your data. It doesn't get the original. So any changes the function makes, it's just changing its own little copy. The original variable back in your main program is totally untouched.
And this is the brilliant fix. Instead of passing the values themselves, we pass their addresses, our sticky notes. Now the function has the exact location of our original variables. So by using that little dereference star, the function can actually reach back into our main program and change the values right at the source. It's working with the real deal, not just a copy.
And boom, just like that, you've unlocked a whole new level of control. Your functions aren't just playing with temporary copies anymore. They can now work directly on your original data, which makes your code way more efficient and a whole lot more powerful. All right, so now that we know how to find data with pointers, let's talk about how to build our own custom data. And that brings us to our second power-up: structures. If pointers are all about location, structures are all about creating your own custom-made data types from scratch. You've probably used arrays before, right? They're great for grouping a bunch of items of the same type, like a list of 10 integer scores. But what if you want to group things that are related but are totally different types? Well, that's exactly where structures come in. They let you bundle different kinds of data together under one single convenient name. So how do we make one? You got to think of it like you're creating a blueprint for a brand new data type. Here, we're drawing up the blueprint for a student. We're saying that any student we create in our program is going to have a place for a name, an ID number, and a GPA. We've got a string, an integer, and a float, all nicely packaged together. So once you have that blueprint, you can start, building actual students from it. You just declare a variable of your new student type. Then, to get to the individual pieces inside, you just use the dot operator. It's that simple. Use a dot to read a value or to assign a new one. Okay, so we've learned how to find data with pointers and how to build data with structures. But the real magic, where C programming just gets awesome, is when we combine these two powers. This is where you can really start to model complex, real-world stuff. And to make this super clear, let's use a practical example straight out of an engineering textbook.
We're going to model an electrical component, a resistor, which has a few different properties we need to keep track of at the same time.
Let's just walk through this code step by step. First, we define our resistor blueprint, our structure. Second, we create an actual resistor variable, let's call it R1, and we fill in its details using that dot operator. And third, and this is the key part, we create a pointer, PTR, and we tell it to hold the memory address of our R1 structure. Now, here is a super important new rule. When you have a pointer to a structure, you don't use the dot. Instead, C gives us a special, much cleaner way to do it, the arrow operator. It's just a hyphen and a greater than sign, and it's basically shorthand for, hey, go to the structure this pointer is pointing to and give me this specific piece of it.
And this table just lays it out perfectly. It's really simple. If you have the actual structure variable itself, like R1, you use a dot. If you have a pointer to that structure, like PTR, you use the arrow. That's it. It's just a simple rule that keeps your code really clean and easy to read.
So after all that, what's the big picture here? What's the main takeaway? Why does getting a handle on these two concepts completely change how you program in C?
It's because you now have two amazing complementary superpowers. Pointers give you the power to find and mess with data with incredible efficiency. And structures, they give you the power to build any kind of custom data you can dream up, whether it's a student in a school database or a resistor in a circuit diagram.
With the power to pinpoint any location in memory and the creativity to design your own data blueprints, the possibilities are, well, they're pretty much endless. You've got the fundamental tools that are used to build everything from operating systems to game engines. So really the only question left is, what will you create?